Okay, welcome to page 8 of the Year 10 end of unit bonding exam. Here's a picture of a car, lovely. Iron is a typical metal. Name the type of bonding shown in iron. Okay, we know 3 types of bonding: covalent, ionic and metallic. Metallic bonding, covalent and ionic bonding, 3 types. I wonder which type iron, being a metal, does. In terms of the iron atoms involved, describe how the bonding shown in iron happens. You should include a diagram in your answer. So, big thumbs down to the 8 or so people that didn't bother reading the question and including a diagram in your answer. That's immediately marks lost. Okay? And again, I'm not an English teacher, I'm not a history teacher, I'm not a geography teacher. I want your answer in bullet points. Lovely to read bullet points for the examiner who can't possibly then get confused about the way that you're thinking. The first thing I'm going to say is that atoms of iron, look, I've used Fe instead of iron to save myself some ink. Atoms of iron lose their outer shell electrons. First point. Second point, the atoms are now positively charged ions. Okay, they're positively charged ions. I've shown the examiner that I know it's the outer shell electrons being lost. I've shown the examiner that I now know that it's no longer atoms, they're positively charged ions. Next thing I'm going to say is the ions line up in a regular crystal lattice, or regular lattice arrangement. Okay. I'm going to go back to the outer shell electrons. I'm going to say the outer shell electrons form a sea of delocalized electrons. Right? Absolutely critical phrase, sea of delocalized electrons. Okay, that's the critical thing in metallic bonding. This sea of delocalized electrons can move between the ions. They're the golden syrup between the marbles. Okay, but don't write that in the exam because they'll think you've gone insane. The electrons hold the lattice of ions together by the force of electrostatic attraction. We remember that plus and minus opposite charges attract, so it's those electrons moving between the lattice that hold things together, and we were going to express that by saying it's the force of electrostatic attraction. Okay. In a normal question, that's probably already earned you 4 or 5 marks, but you're required to do a diagram. So here's a diagram. It shows ions in a regular structure, and you could have just drawn that ion like that. Okay. And here are my electrons in the sea of delocalized electrons. Okay. But critically, every diagram either needs labels or a key. No key, no label, no marquee. Okay, so here's my key. Fe plus is an ion. Great. E minus is a delocalized electron. Okay, 6 marks. That's just an absolute gift. If you see that in the exam, you know, it's happy days. Urgently need to be able to, in bullet points, plop out how metallic bonding happens. This question is about magnesium, isn't it? The electronic structure of a magnesium atom is shown below. Oh, we've even got the answers here for us. The nucleus contains protons and the particles with the smallest relative mass that move around the nucleus like this. Whee! I'm moving around, I've got a small mass. Are called atoms of magnesium are neutral because they contain the same number of electrons, and if we didn't get 3 marks on that, why didn't you get 3 marks on that question? Why? What don't I understand about atomic structure? Because this is absolute 101 basic stuff.